Good morning, everyone. Thank you, Paul, for the introduction. I'm glad to be here today to speak to you about this part of our work that we just published in the new version of the guide. Actually, this morning, my talk will be focused on a part of what Ashok just addressed. He took the document as a whole. He already provided us with some basic and important information on Chapter 6. I'll just go over a little more details to complement what Ashok just addressed. So the idea in this presentation this morning is to go over rapidly what are the methods and tools to supplement the information that we collect on site when performing the assessment of a structure. And in addition to the techniques, methods that are available that we can think of, how to sample the structure. And sampling, it means not necessarily means getting a chunk of concrete out. It's also sampling for NDT as well, so for non-destructive testing. We can subdivide, as Ashok has just showed us, we can subdivide the methods for evaluating the condition and properties of materials on a concrete structure in two main categories. First, field-based, non-destructive, as well as the destructive tests. And we can also take samples out of the elements, out of the targeted parts of the structure to conduct laboratory-based tests in order to provide us some insight, some more in-depth understanding of what's going on, or at least to provide us an overall view of the actual condition of parts or of the structure, or of the structure as a whole, depending on the size, condition, and different aspects that we'll touch base in the following minutes. First, before getting there, it is needed to evaluate why and to what extent we should sample and perform either field or laboratory testing. And this will depend on actually this has to be preceded by a review of the actual information that we have of the structure. So and this is part of Chapter 4 that was just touched base by Ashok. And it has to be based then, and it is very directly based to the actual results that we get out of the field investigation. And in deciding what we'll do in terms of further testing, either on site or in the lab, it also has to relate very much. It's pretty tied up to the actual rehabilitation plans that the owner and engineer has in their site when performing the assessment. The requirements for testing, it depends on the different needs. It might be to better document what is the condition of the materials, what are the materials, what is the condition, what are the distresses, the deterioration of or defects that exist, that developed in elements or in the structure as a whole. It might be to support a load carrying capacity evaluation that is needed. It can also be triggered in order to answer questions arising from the needs of new requirements of a structure. And in some case, depending on the rehabilitation plan, the change envisioned might alter some aspects of the construction of the structure, serviceability, and so on. So these are different reasons or causes that will trigger in some instances further testing, either on site or in the lab. There are many analytical and testing tools available. So depending on the actual considerations that we just touched base, we have to select the ones that will yield the data that will be useful and reliable at the same time. And this supplemental testing most of the time also will be helpful in better assessing actually what is the condition of the structure based on the exposure that has been that has caused actually the different defects, deterioration that can be found on the structure. So the sampling and testing plan, depending on the size of structure, the complexity, the actual condition, the different type of distresses that may be found, are to be based on the licensed design professional's judgment. And it goes from very simple approaches like Ashok was showing, for sounding the surfaces, to different techniques, much more complex, much more sophisticated, to get an insight of what's going on inside the elements. Like you got a radar to, for instance, to evaluate the lamination over a concrete deck. So the selection of these methods that are adapted to the actual condition and situation of the structure, it will depend on a variety of things. It can depend, for instance, on the actual variation in material properties within the structure, the extent over which we want to, predict, evaluate, the actual condition based on the results that we'll get. Sometimes, depending on the complexity of structures, some areas are difficult to access. So testing or sampling is not possible in all areas. Some areas are either or very critical in terms of structural stability. So this has to be taken into account for sure. It also will depend on variations of in exposure, loading, and use of the structure. And also it has to be depending on the location you're doing the assessment, depending on the proximity of services, of expert services, the availability of sampling equipment, as well as qualified test personnel to perform the sampling and testing. So basically, the selection of test methods will have to consider, the actual potential cause or sources for the problems, the accessibility, as well as the structure, geometry. And in some cases, extra care must be given to the actual, for instance, loading events, special or exceptional loading events that might have caused the problems that we want to evaluate, to assess on the structure. For instance, seismic, wind, gravity overload that might have occurred and that might have driven the actual problems that we want to identify and circumvent. So in order to perform these different tests, either NDT tests and lab tests after that, sampling is a very important aspect. So it's got to be, when the sampling plan is designed, it's got to be representative of the structure. Different also aspects have to be considered especially when invasive sampling is being conducted, when coring or openings are performed. Primary reinforcing steel has to be, as much as possible, prevented from any damage. And when samples are taken out of the elements, they got to be care has to be taken in order to maintain their actual condition as much as possible as they were inside the structure in order to yield results that will be representative of the actual structure condition. In some special, with some special structures, historic structures, architectural structures, there are some also special considerations that has to be implemented when doing an assessment. As much as possible, for instance, historic structure, we got a sample as well as architectural structural, the same in less visible locations. We got also to put extra attention on the way when samples are taken out on the way, the holes, core holes will be repaired. And in some cases, testing will just not be possible. And in those cases, there are documents like, for instance, ACI 562, ASC, ACI 41, provide some guidance on the way to collect data in order to support, depending on the year or the era the structure was constructed, to provide some representative data in order to perform conservative evaluation of some of these elements or structure at stake. Just to let you know, in that regard, we have just undertaken, there's a task group that has been formed, and the development of a new document specifically devoted to rehabilitation of historic structure is underway, and it's one of the task group of our committee. And the number of the document will be at 364.2, a guide which should be available in a few years from now, and which will complement actually our main guide in the committee. Then testing and evaluation. So the actual test, when we decide as to provide us with this extra information, this is the goal, to provide us with the extra information over that we can get from the existing condition, strength and serviceability, in order to interpret adequately what's been observed on the site, sounded in terms of surfaces. And these data really are intended to extend our understanding and to make sure that the actual diagnosis that we'll be able to carry out at the end will lead to the proper interventions, and this is the goal. So we can actually, and we have in our guide, we have two tables summarizing the different test procedures that can be carried out on hardened concrete as well as steel reinforcement in order to supplement this information and to assess correctly the existing structure. First, let's talk a little bit about the hardened concrete tests that are recommended. Actually, we can subdivide these different tests into three categories. First, there are the mechanical tests, which basically compressive strength, tensile strength, flexural strength. We can also evaluate static modulus, dynamic modulus. There are a list of standards that are recommended. There are primary tests, secondary tests, and the different tables in order to provide a very global overview of what is possible. I've put in the, this is part of the first table, the one that relates to hardened concrete here. I've put in green shaded, in the green shaded cells, those DT, so to speak, and the other ones are to be performed on samples that are taken into the lab. So typically, one of the most spread the most common test that is being performed when taking cores to the lab, when assessing concrete structure for typically, for sure, it's compressive strength. This provides information on the actual quality, uniformity of the concrete, and it, as well as when needed, it provides information when properly treated to use to evaluate the actual on-site, in situ strength that can be used in performing a structural evaluation. So, but for sure, this needs some treatment, and this needs some special considerations in terms of sampling and the number of samples that are being considered, which is dealt with in a standard that I will refer to a little later on. So as Ashok was saying, we can actually perform destructive tests on samples, but on site we can also get an evaluation of strength with different tools. For instance, this is the Schmidt hammer or rebound hammer, and you can find actually there, a well-developed document by ACI 228. It's ACI 228.1 that gives some guidance in using this type of testing and how to relate it to the actual strength of concrete that is being evaluated. So to provide a better insight of the actual durability characteristics and properties of the concrete in the structure, the different properties or type of characteristics that are being addressed is air permeability, electrical resistance of concrete, density, resistance to chloride penetration. So these properties actually will trigger actually the actual effect, or not trigger, but will condition the actual effect of the exposure conditions on the concrete. So just as an example is, for instance, the resistivity test that can be performed. It's an NDT test that can be performed on site to evaluate resistivity of the concrete in a cover. So the third category of tests that can be performed on concrete is actually, it relates to the actual condition of the concrete on site. A first subset of condition that can be evaluated: moisture condition, chloride, iron content. For instance, showing here a chloride profile from the surface, so that can be evaluated by extracting some samples of cement paste in the concrete at different depth, and it allows us to evaluate the actual contamination of the concrete in different areas, and to evaluate eventually the vulnerability to corrosion afterwards. We can also evaluate the actual carbonation at different depth inside the concrete cover, and to evaluate further the susceptibility to corrosion or initiation or eventually development in the first few layers of reinforcement close to the surface. The second subset of tests that can be performed to better evaluate the condition of concrete on site. First, one that is being performed typically in any assessment, the different methods consisting in sounding the surface, the hammer like this, or with a chain drag, a little more, especially on the large horizontal surfaces. This is, in connection with the actual visual examination that is being performed on the different members of a structure being assessed. So these tools are, always used in order to evaluate the integrity of the surface in the different areas and detect the presence of defects and typically delamination. There are tools that have been developing on the NDT side. For instance, this is the georadar that are used very effectively to sound large surfaces and evaluate the presence of defect, delamination, and so on. There's also thermography, is another technique which can be used very effectively in on certain types of structures, certain circumstances, to supplement the actual sounding of the surface that we can perform with simple tools. This is, Shuk talked about it earlier, this is the impact echo method, and also widespread method nowadays, which can provide very useful results in evaluating the integrity of concrete elements on site. And in addition to all these tests, these NDT tests, and there's a variety of them nowadays, in addition to the ones that I just talked about, in order to confirm, the actual results of these different experiments, confirm in the lab, different types of pathology, petrographic examinations is very central and is very, critical in many studies, in many assessments. So, and petrographical exams, it goes to using, from the visual exam to SEM through optical microscopy. It uses those different tools in order to assess the different phases, assess the different symptoms in order to confirm different pathologies. Like, for instance, this is an example of ASR problem in concrete. You've got your freeze-thaw damage in concrete. So in order to really confirm these types of problems in concrete and to point the finger on the right cause, petrographical examination is typically the final ultimate tool in order to cap the analysis. So this is we've got a wide set of tools for concrete, and because as you know, there are different. There's the variety of problems that may arise in concrete depending on the exposure condition, depending on the components, is rather wide. For reinforcement and for evaluation of its condition, and sometimes to evaluate the characteristics when we don't have the plans, we don't have the original construction details. Sometimes we need to detect where's reinforcement, what type of reinforcement we have. Is it round bars? Is it, so there are different tools, but for sure there are much less types of tests that are being considered for evaluating condition characteristics of reinforcement. So typically, it comes down to evaluating where's reinforcement, so we can use the carver-meter or paco-meter, depending on the terms you're using, which is a tool which allows you to evaluate the location, the cover thickness, and it provides also, depending on the detailing, whether it's very where the rate of reinforcement is not too high. It provides you some information on the size and depth of the first layer of reinforcement. You may want, especially when you've got section loss due to corrosion, to evaluate the size of reinforcement in order to follow and assess the existence of corrosion problems. One of the most widespread tests here is the AFCEL test, where you measure the actual potential in the reinforcement over an element. And there are other tests like linear polarization that will provide you additional information, for instance, to evaluate the rate at which the problems are developing. And then there are some other, for reinforcement, some tests for instance, mechanical testing, tensile testing, chemical analysis, and also as well as protective coating thickness that complete this set of tools for the evaluation of reinforcement in providing more details for a complete assessment. So in general, NDT methods are to be, we are preferred for sure because it reduces, the need for sampling and subsequent repair needs. For sure, we need to, depending on the actual condition, oftentimes we'll need to sample and to perform some extra tests in the lab, and the sampling must be designed in order to answer the actual needs and to be representative of what we have on the structure. And like Ashok was saying, in very specific cases, we'll have to perform some load testing on site, but these for sure require some detailed analysis, because in some cases feasibility may be quite limited depending on the technical and economical constraints. So just because I think time is flying, the important thing about sampling is, it's got to be representative, and in order to do so, appropriate care must be taken in all phases, from obtaining to storing, and in the meantime identifying, handling properly whatever samples that have been taken out and taken to the lab. And one of the critical phases in order to provide the actual information and data that is necessary to ultimately come up with accurate assessment of what's going on is the sampling plan. And the scope of this sampling plan, it depends. Sometimes we'll need some statistical information about the properties of concrete in a structure, and in some cases it's much more specific. We'll need characteristics to better assess some unusual or extreme conditions in a specific component. So this has to be evaluated when designing the sampling plan. Another aspect is random distribution, and this consideration depends on what is being looked at. In some cases, simple structures and with condition that does not show too much variation from one end to the other, the random consideration is devoted to the whole structure. In some other cases, we'll have to subdivide the structure or the member in sub-areas, and in these sub-areas then sampling should be random in order to provide us with accurate and useful information. So rapidly sample size, we've got a lot of guidance in different documents like ASTM E122, like Ashok was saying before, ASTM C42 as well, ASTM, not ASTM, but ACI 214. And it depends on the structure, the size, the extent of problems, and also the available information at the time the tests are being conducted. And let's not forget that concrete is not a perfectly isotropic material, so to speak, especially in the vertical direction, because it's cast with gravity, and it's subject to different, eventually different consolidation problems, bleeding, compaction, which might not be as good in all areas. So this got to be kept in mind when doing, when coring elements in this direction in particular, in some components like columns, deep beams, and so on. So this is something that has got to be cared of. So rapidly core sampling, we've got guidance for the procedures to properly extract cores. And again, the number, the size, location will depend on those different considerations that we've already discussed. There are specific considerations with regard to strength, and the main message here is it's important to keep in mind that average strength from cores, the raw average strength is one thing. It provides information on the actual condition of the structure, but when it's time to use this information to perform structural evaluation, these data needs to be treated properly under the guidance, for instance, of ACI 318 and ACI 562. In some case, sawed beams could be used instead of cores, but in order to, especially when you have both cores and beams, in order to interpret correctly the different results that you might get, because you'll obviously get different results when it comes to strength evaluation with these different types of samples. It can be interpreted under the guidance of ACI 214 and SCI 11. Typically, broken concrete, it can be used, can be useful to provide further information with regards to chemical, physical deterioration of concrete, but will generally avoid it completely when it comes to strength evaluation. Finally, just a few words about, when it comes to steel. Steel can be sampled in accordance with the ASTM A370, and for sure, there's got to be some, some care given to the location, the number of samples that will be taken, and location depending on if we'll typically want some location where we have main reinforcement, but it's got to be limited in areas, the spacing. In Ashok's presentation, we saw that it should be at least be spaced over the length of development, and there are also some limitations depending on the size of the member or the structure that is being sampled. Different information can be taken from samples taken out, the grade, mill marks, newer, more recent reinforcement might need much less sampling, whereas in older structure, there might be square bars, smooth bars, iron-based reinforcement, and it might require a little more extensive sampling. And finally, when performing tests, especially for mechanical properties, it has to be in accordance with ASTM A370. When it comes to pre-stressing, for obviously pre-stressing needs very much care, and to make sure that we satisfy safety procedures, and typically we'll limit ourselves in unbonded tendons to visual exams and lift-off tests in areas where it's possible to do so when access is possible. So just to close on this, for sure, when doing testing, all the requirements, typical requirements for test reporting must be observed. But in the present case, some aspects we need to insist on, notably the alignment of sampling tests and sampling testing performed with the plan document, the assessment of test result and extrapolation of those to the actual concrete structure that being assessed as a whole. How can it be used to conclude and to make a global diagnosis of the actual structure? And also in some cases, some more where deterioration is more complex, problematic, or extensive, sometimes recommendations for some additional testing or any other might be taken, which might for sure affect the actual rehabilitation plans that will come after. So thank you for your time. This is the chapter 6. Thanks. If you have a few questions, we have, I think, a little time.
Doctor, my question is, if I want to reinforce a concrete structure, I am worried about the incompatibility of materials. If I use steel to reinforce it, is it going to affect my structure? Is it better to use any other kind of reinforcing? Thank you.
When you're saying you fear there might be a problem of compatibility, in what respect?
In the deformation, because the steel tends to deform more than the concrete. So the periods of both materials will be different, and that will lead to incompatibility of materials. If I use, for example, profiles of steel to reinforce the structure.
I'm not sure you're talking about the compatibility between new steel and existing steel, or I'm not sure I'm getting.
I mean, new steel, but the existing structure is made out of concrete. Or, for example, if I want to add a new store, and it's gonna be from just steel.
Is it gonna steel structure over existing concrete structure?
Yes.
And so, what is so now I understand.
Is it gonna be any incompatibility of materials between steel and concrete?
But this can be taken into account in the design. But it for sure that the concrete and steel have different behaviors in terms of deformations.
Yes, yes, the deformation.
But now you're having, it's not a repair as such. It's a steel structure over reinforced concrete structure. Is that it?
Yes, I mean sometimes they use, for example, steel beams for repairing some deflection in the slabs. So my worry is about, is it going to be any incompatibility of the materials in the deformation because steel has different behavior than the concrete?
Oh, okay, now it depends on the way the connection between the steel and the concrete member.
Okay.
But this has to be taken into account at the design. Yeah.
Okay, thank you.
Are there any special procedures or testing methods for buildings subjected to fire?
Yes.
Fire attack, or high-rated temperatures? Do we have testing methods for these elements?
When you say procedure in terms of sampling, in terms of
sampling, yes, the way of taking samples for comparative.
I think it's
we can use
most of different approaches here that are they are applicable to a variety of types of problems, including fire damage, and then fire damage is oftentimes will be evaluated. And there was a part in the table that covered the tests for hardened concrete. There's fire damage is addressed, and petrographic exam will be one of the main tests that will provide information on the extent of damage, the depth, and evaluation of the actual maximum temperature that was reached during the event.
Yeah. Thank you.
Yeah, I'm looking for